This is part 2 of the classifying quadrilaterals with coordinates video. We're on the back side and we're ready to start actually drawing quadrilaterals and classifying them using slopes and distances. So I'll start with this first one right here and I'll show you how to do this. First, let's start by taking a look at this graph. We got 4 points, A, B, C, and D. And let's just connect those points with a ruler. And you may be able to guess what kind of quadrilateral this is right off the bat. It looks kind of like a kite. Right? It looks like these two sides are congruent and those two sides are congruent. But I'm not 100% sure that is a kite. We're going to have to do a little bit of more research, get a little more information, do some calculations to actually confirm that this is in fact a kite. Now we have two big kinds of calculations we can make here for each of these sides. We can check the slopes of each side, and that'll be useful for finding if there are any parallel sides or perpendicular sides. And we can also check the distances of each side. So what we're going to do is draw a table just like this. We'll draw a table with two large headings of slope and distance at the top. Then we'll draw rows for each of the sides of our quadrilateral. Again, we've got side AB, BC, CD, and DA ending right there, DA. Now, you don't have to organize your table like this, but this is probably the easiest way to do it, to neatly write down all the slopes and distances of this quadrilateral that we're going to need to calculate. So let's start right in with the slopes here. The slope of AB, so that's this slope right here. Remember, to find slope, there's a bunch of methods you could use involving the slope formula, but I'm going to prefer to use rise over run because I've got the graph right in front of me. So my rise here is 3, my run is 1, which means my slope is going to be 3 over 1, or that's just equal to 3. Pause here and try and fill in the slopes for the rest of this, BC, CD, and DA. Pause now. The answers will start coming up in 3, 2, 1. Alright, from B to C, let's see. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that's 4. That is 6. So my slope is going to be, let's see, 4 over 6, which simplifies to 2/3. From C to D, 1, 2, 3, 4, 5, 6. 6. 1, 2, 3, 4. Going more back 4. This is the negative x direction over here. Negative x, positive x. Okay, so we're going backwards 4 in the x direction. So my slope will be, let's see, my rise is negative 6. My run was negative 4. A negative over a negative will make a positive, and 6 over 4 simplifies to 3 over 2. So positive 3/2. And then D back to A, going down 1. Minus 1, and back in the negative x direction 3, so negative 3. So let's see, my slope will be negative 1 over negative 3, and negative over negative is a positive, so the slope there will be 1/3. Now for distances. Distance is a little trickier, but since I've already found the kind of rise and the run from one point to the next, distance using Pythagorean theorem will actually be quite easy. From A to B, let's take a look. I've got this side is 3 and this side is 1. And I want to find out what this side is. Call this x. So I can set up a Pythagorean theorem of 3 squared plus 1 squared equals x squared. 3 squared is 9. 1 squared is 1 equals x squared. 9 plus 1 is 10 equals x squared. And again, I'm going to take a square root at the end there. So the distance here is going to be the square root of 10. Or if you'd like to use a calculator, we can find that the decimal approximation to the square root, the square root of 10 is going to be about 3.16227, so let's round that to 3.16, 2 decimal places. And so 3.16 as an approximation. What I'd like you to do is pause here and try and finish the other 3 distances. Okay? Pause here, the answers will start coming up in 3, 2, 1. Alright, so from B to C, we're going up 4 and over 6, so we can set up 4 squared plus 6 squared equals, I'll call this x squared. Again, x is this distance we're looking for. 4 squared is 16. 6 squared is 36 equals x squared. 16 plus 36 yields 52 equals x squared. Got to take square root to get the x by itself. The square root of 52, we can actually break down the square root of 52 and simplify that a little more. 4 divides 52, and 4 is a perfect square, so we can take the 52 and break it down into the square root of 4 and the square root of 13. The square root of 4 is 2, and the square root of 13, well, we can't simplify that any further, so this can be written as 2 square root 13, or as a decimal, it's about 7.21. Again, using the calculator and rounding to 2 decimal places. CD, the calculations for CD, we've got -6 and -4. Right, -6 squared plus -4 squared equals x squared. -6 squared is positive 36. Remember, negative times negative is a positive. -4 squared is going to be positive 16 equals x squared. And you can start to tell this is going to end very, very similarly to BC. And in fact, it does. 36 plus 16 is 52 equals x squared. We could break that down, that square root of 52, into 2 radical 13, and that's going to approximately equal 7.21, just like BC did. And dA, we're going down 1 and over 3, so that's -1 squared plus -3 squared equals x squared. Finding that distance using Pythagorean theorem, we get 1 plus 9 equals x squared. We get 10 equals x squared, and the square root of 10, well, that looks a lot like AB, right? The square root of 10 is going to approximately be equal to 3.16. Now, you might be asking yourself, why did we find all these slopes and distances? Well, we found them so we could use these as evidence to help us figure out what kind of shape this is. So we look at the slopes and distances and what kind of patterns we see. Let's start with the slopes. If the sides are parallel, then the slopes would be the same. Remember, because parallel sides have the same slope. So looking at these, are any of the slopes the same? 3, 2/3, 3/2, 1/3. No, none of them are the same. So let's write down that piece of information down here. Since none of the slopes are equal, there are no parallel lines. What about perpendicular lines? Are there any 90-degree angles here? Well, that would require a keep, flip, change. Are there any keep, flip, change slopes here? Any opposite reciprocal slopes? Well, there aren't. Remember, because you might think that 2/3 and 3/2 are opposite reciprocal slopes, and they are reciprocals, right? The fraction is flipped over, 2/3 to 3/2, but they're not opposite reciprocals. They're both positive. One would have to be negative to create that opposite reciprocal or keep, flip, change slope, and so, as a result, there are no perpendicular lines and no 90-degree angles. Let's include that down here. Since none of the slopes are opposite reciprocals, there are no right angles. What are the distances? Well, if we look at the distances, we do see a pattern, right? Both AB and DA have a distance of square root of 10, right here. And that means that this side and this side are congruent. Similarly, BC and CD have 2 square root of 13 as their distance. That means that this side and this side have the same length, and so they are congruent. Let's write that down at the bottom. For AB equals DA, and the distance for BC is equal to CD, 2 pairs of consecutive sides are congruent. Now we've gotten all the evidence, all the justification to go ahead and say this is a kite, because all this evidence we've gathered fits the definition of a kite. Let's finish off with that. Therefore, ABCD is a kite by definition. And that is basically how you want to approach doing these kind of coordinate proofs, right? Maybe you make your graph first, you find the slopes, you find the distances, you gather some evidence based on the slopes and the distances, and then you make your conclusion based on those patterns that you've noticed. Let's try one of these without a coordinate grid. So a quadrilateral ABCD, we're given the 4 points, but no graph. We actually can do this without using a graph. Just start by drawing out the table, just like we did above. Now that I've got my table, I'm going to go ahead and try and find the slopes and the distances between all these points. If you'd like to go ahead and draw a graph of this first to get a better idea of what you're looking at, that's fine. You can draw the graph and do it just like we did this first problem up here. However, I'm going to try and do this without looking at the graph, just to challenge myself and show you a different way of looking at it. For this, we're going to use the formulas, the slope formula and the distance formula. Let's take a look. From A to B, how am I going to find the slope? Well, that's easy. Let's use the slope formula. So I will do my y2 minus y1 over x2 minus x1. And I'll get 4 over 4, which is just a slope of 1. Pretty easy. Pause the video here and try to find the slopes from B to C, C to D, and D back to A. The answers will appear, all of them, on the screen in 3, 2, 1. And so here are my slopes. AB is 1, BC is -1, CD is 1, DA is -1. With all the work, pause if you'd like to check out that work. What are the distances? Well, since I don't really have, a graph in front of me, I'll go ahead and use the distance formula for this one. Although, like I said, if you want to, go ahead and draw your graph. So let's see. X2 is 4 minus X1 is 0 squared plus, let's see, 4 minus 0 squared gives us 4 squared plus 4 squared under that square root still. 4 squared is 16 plus 16, still under the square root. That's the square root of 32. And can we simplify the square root of 32? I think we can. 16 divides 32, and 16 is a perfect square. So square root of 16 times the square root of 2, which gives us 4 radical 2 as our distance. Okay, sounds good. Again, if you'd like to draw the graph of this and do it that way, just as fine. In any case, pause here and try to fill out the rest of these distances. The answers will be coming up on the screen in 3, 2, 1. And here are distances. They all happen to be the square root of 52 or 4 radical 2 when simplified. All of them, AB, BC, CD, and DA, and there's a little bit of work in case you'd like to take a look at that. Now as we start to analyze these numbers, first take a look at the slopes and look for parallel lines. Are there any parallel lines? Well, there are. When we take a look at slope AB and CD, those have the same exact slope, so they're parallel. Same thing with BC and DA. Those have the same slope of -1, so those are going to be parallel. Let's jot that down at the bottom. In quadrilateral ABCD, AB is parallel to CD because both sides have a slope of 1, and BC is parallel to DA because both sides have a slope of -1. Are there any perpendicular slopes here? Are there any opposite reciprocal or keep flip change slopes? Well, there definitely are. 1 and -1 are actually opposite reciprocal slopes, even if they don't seem like it. Because 1 we could rewrite as 1 over 1, and -1 we could rewrite as -1 over 1. So you can see from AB to BC, the numerator and denominator are flipped, and the sign has been changed, positive to negative. Let's go ahead and write that down over here. In addition, all 4 sides are perpendicular to each other, and they form right angles, because the slopes of each side are opposite reciprocals, like we just saw. What about the distances? Well, the distance for AB, BC, CD, and DA are all exactly the same. What does that mean? Well, it means that all the sides of this quadrilateral are going to be exactly the same, and they're congruent. Let's jot that down over here. Lastly, since all 4 sides are the same length of 4 square root 2, they're all congruent. Now we think to ourselves, based on the evidence we've found, what kind of quadrilateral is this? Well, remember, it's going to have those opposite parallel sides, it's going to have those right angles, and it's going to have all 4 sides being exactly the same length and congruent. What shape could that be? It can only be a square. It's got all 4 congruent sides, all 4 90-degree angles. Let's finish out our explanation right over here. Therefore, ABCD is a square because all the evidence and calculations fit the definition of a square. That ends our explanation. If you had chosen to graph quadrilateral ABCD from the start, that's okay. In fact, it may have helped you to see that this actually should look like a square. Your calculations still would have been exactly the same, although your work may have been a little bit different, and your explanation would have been just about the same. And so whenever possible, I do encourage you to actually graph the shape before you do all of this work, unlike what we did here, because it helps you see more visually what's going on. However, I want to show you that you could, in fact, do these calculations without seeing the picture. This last one, quadrilateral TRMH, we're not going to do in this video. I want you to do this one by yourself, bring it to class, and we'll talk about it as soon as we come in. Remember the 4 important steps to doing one of these problems? 1. Draw yourself a graph, just like we've done for the past couple problems. 2. Fill in the table and find all the slopes and distances for each side. 3. Look for equal slopes, those are parallel sides, opposite reciprocal slopes, those are perpendicular 90-degree angles, and equal distances, those are congruent sides, and write your explanation. Lastly, decide on a final name for each quadrilateral. Is it a rectangle, a rhombus, a square, or trapezoid? In any case, make sure you try this last problem, and who knows, maybe it'll appear in the next video check. I'll see you then.